What do elite cross-country skiers, cyclists, long-distance runners, and swimmers all have in common? They have all been documented as having an incredible ability to use a lot of oxygen during a maximal exercise test, known as a VO2max, which is the gold standard tool used to assess cardiorespiratory fitness. Okay, so if we wanted to see how you rank up to these athletes, how do we measure your oxygen consumption? One indirect way to do this is based on what's known as the Fick principle, which simply put states that the amount of oxygen that you breathe in minus the amount of oxygen that you breathe out must equal the amount of oxygen that your body used throughout a given period of time. So then, our main measure for our VO2 max test is going to be the oxygen that we breathe in and the oxygen that we breathe out. Therefore, it's essential that we have equipment capable of measuring oxygen in the air. This requires the use of metabolic carts, which are equipped with gas analyzers and flow meters to estimate the volume of oxygen being fluxed through the system. Once calibrated, and the participant is set up with a closed system breathing device, ensuring that all the air that he or she breathes in and out is being directed towards the metabolic cart, then you're ready to begin the exercise test. We are going to use a bike test as an example, as this is a very commonly used exercise modality in research, hospitals, and athletic testing. You are testing Jordan, 23 years old and weighs 75 kilos. He tells you that he is a competitive dancer and regularly weight trains. Using this table, you can estimate him to be an active, trained individual, but in exercise modalities that likely aren't as taxing on the cardiorespiratory system as, let's say, cycling or swimming. So you guess that his VO2 max relative to his body weight is on the lower end of this range at 52 milliliters per kilogram per minute. Given he is 75 kilos, we are predicting him to consume 3.9 liters of oxygen per minute. You can use this value to get an idea of what the maximal amount of power he will be able to produce using his aerobic or oxygen dominant energy system using the following equation. This tells us that we should expect Jordan to reach his VO2 max around 305 watts. Next is to set up the protocol, which will include a series of stages that typically last 2 to 3 minutes and progressively increasing intensity by 15 to 40 watts. The entire protocol should last between 8 and 14 minutes to ensure that Jordan doesn't fatigue before reaching his VO2 max. So a protocol for Jordan might look something like this: 2-minute stages starting at 150 watts and increasing by 30 watt increments. And just as a side note, if you're using Monarch cycle ergometers that require you to manually load the flywheel, you will need to calculate how much weight to put on the bike for each stage, based on a set pace, or RPM, that the participant chooses. So the weight on Jordan's bike will look something like this if he decides to pedal at 80 rotations per minute. And that's your plan. But last thing, you may have to adapt the protocol on the fly if you notice the individual is fatiguing too quickly or too slowly. Too quickly, and we should consider making the stages longer or lowering the workload increase per stage. Too slowly, and we should consider making the stages shorter or with larger workload jumps. So this takes some experience in being able to predict when a person is nearing VO2 max. Normally it's obvious from the grimacing bicycle face, but to get around the poker-faced individuals, here are some tells. Approaching an age-predicted heart rate max. So for Jordan, it will be in the 190s. A respiratory exchange ratio, that's the VCO2 VO2 ratio, which is around 1.1. This essentially means that your body is starting to more predominantly use the anaerobic energy system, as opposed to the aerobic. And a breathing frequency nearing 60 breaths per minute. Your data should look something like this. Observing this plateau in oxygen despite an increase in workload tells you that the participant is at their VO2 max, which is pretty difficult to achieve unless you are very well trained or well motivated. And so, for most recreationally active individuals, the data might look something more like this, which we would call a VO2 peak rather than a max.